All right. So, suppose you're traveling from Philadelphia, Pennsylvania to San Diego, California. Do you think the probability of rain in Philadelphia affects the probability of rain in San Diego? No. It wouldn't affect it because weather moves from west to east anyway. So the answer is no. Weather moves from west to east. These are independent. The weather in each location is independent from the weather in the other location. Okay? Now, what we're going to do today is look at compound events, an event and then another event. Sometimes they're independent of events, but sometimes they depend on each other. Okay? Independent events are like flipping a coin and rolling a die. What's the probability of flipping a head and rolling a 6? Well, flipping a head, I have either heads or tails, right? So it's 1/2 heads, 1/2 tails. To roll a 6, I have a 1 out of 6 chance of rolling a 6. So if I do both of those, what's the probability of flipping a heads and rolling a 6? Well, 1 out of 6 times 1 out of 2, which is 1 out of 12 chance of doing both of them at the same time. That's a compound event, okay? So, if you choose numbers and then spin a spinner, those are independent of each other. But if you pick a number from a deck of cards, and then pick another number, pick a card, and then pick another card, the first card or the second card depends on the first card pick. Because if you pick the ace of spades, can you pick the ace of spades again? No. So the second pick depends upon the first pick unless you put it back. Okay? So this is like a dependent, but this is an independent. All right, what happened? Where'd they go? We're back. All right, so when you have independent events and two events, you just multiply them together like I did with the flipping the head and rolling the die. Okay? So if you have 5 red pens, 6 blue pens, 3 black pens, okay? There's 14 total pens. And if you have 24 silver paper clips and 16 white paper clips, there's 40 total paper clips. What's the probability of selecting a blue pen, which is 6 out of 14, and a white paper clip, which is 16 out of the 40? Well, you just multiply them and reduce your fraction. They reduce to 6 out of 35. Okay? So if you roll a standard number cube, what's a standard number cube? A dice, a die, and there's only one. Okay? What's the probability of rolling a number less than 3? How many numbers are less than 3? So it's a 2 out of 6 chance of rolling a number less than 3. If you spin the spinner, what's the chance of landing it on a vowel? How many vowels do you see up there? 1 out of 4. So if we reduce our fractions, 2 out of 6 is 1 out of 3. So you take 1 out of 3 times 1 out of 4. You got a 1 out of 12 chance of rolling a number less than 3 and then getting a vowel on the spinner. Now, events that cannot happen at the same time are called mutually exclusive events. For example, you cannot roll a 2 and a 5 at the same time. So the chances of rolling a 2 and a 5 at the same time are 0. Okay? Those are mutually exclusive. Now, you can roll something or something else. That's when you add them together. Like if you roll a 5 and a 4. Well, 5 is a 1 out of 6 chance. A 4 is a 1 out of 6 chance. So then you got a 2 out of 6 chance or a 1 out of 3 chance of rolling a 5 or a 4. Okay, because they're 2 numbers out of 6 numbers. Student athletes at a local high school may participate in only one sport in a season. During the fall season, 28% played basketball and 24% were on the swim team. What's the probability that an athlete who is selected is either plays basketball or on the swim team? Okay, well, you just add them up. 28% and 24% make 52% because they're mutually exclusive. They cannot happen at the same time. So during the spring season, 15% play baseball, 23% are on track. What's the chances of either being, if you grab a student at random, they're either playing baseball or being on the track team? Well, what's 15 plus 23? 38% are involved in either one of those two. Now, overlapping events are events that happen at the same time, but you double count something. Okay, you double count something. So we're going to skip through that and go straight to here. Okay, what's the probability of rolling either an even number or a multiple of 3? An even number or a multiple of 3? Well, the even numbers are 2, 4, and 6, which is a 3 out of 6 chance of rolling an even number. Okay, a multiple of 3 is either 3 or 6. So you got a 2 out of 6 chance of rolling a multiple of 3. What number have we counted twice? 6. So we have to erase one of them. So erase 1/6 from there. So 3/6 plus 2/6 is 4/6. Or 3/6 plus 2/6 is 5/6. Minus 1/6 is 4/6, which is 2/3. Okay. I'm going to cover that a little bit better when we go into what you'll see on your homework here. All right. A or B. When you have an or statement, do you multiply or add? You add them. When it's A or B, you add them. So this would add up to 88%. Okay? If you pick a ball from a basket of red and pink balls and you replace the ball and pick another, is that independent events or dependent events? Independent, because you replaced the ball. If you would take a ball out and not replace it, then it would be a dependent event because it depends on what you first chose. All right, so you spin the spinner. The spinner lands on an even number. How many even numbers are on that spinner? 2 out of the 4. You choose a tile from a set of tiles, numbered 1 to 10. What's the probability you choose an odd number if they're numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? 5 out of 10 are odd numbers. Well, this is 1/2, and this is 1/2, and you multiply, so you get 1/4. Okay. Envelopes. What's the probability of selecting a red or a blue envelope? Well, red envelope is 1 out of 8, because there's 8 envelopes there. A blue is 3 out of 8. And since it's an or, do we multiply them or add them? Add them. So it's 4 out of 8, which is half the time you have a chance of choosing a red or a blue. Okay. Now, this is where that overlapping events comes in. Cassie, shut your lid so you can pay attention to what we're doing. A set of cards has 4 suits. 2 suits are red, 2 suits are black. In each suit, there's 13 cards. There's 2 through 10, as well as Jack, Queen, Queen, Ace. What's the probability of selecting a card that's a 6? What are the chances of selecting a 6? How many 6 cards are there in a deck of cards? 4, 1 in each suit. So that's a 4 out of 52 chance of selecting a 6. What's the chances of selecting a black card? Half of them, which is 28, 26 out of 52, right? Now, did I count any cards twice? Yeah, the 2 black 6s I counted twice because I counted them with the 6s and I counted them with the black cards. So I have to subtract 2 of the 52 cards that I counted. Okay, so 4 plus 26 is 30, minus 2 is 28 over 52. Divide that out by 4 is 7 out of 13. There's a 7 out of 13 chance I'm going to pick either a 6 or a black card. A math department at a college has professors and teaching assistants that are either male or female. All right, if they have 8 male professors and 9 female professors, 10 male teaching assistants and 9 female teaching assistants, they have 17 professors and 19 teaching assistants, they have 18 females and 18 males. Both these add up to how many people? 36. Okay. All right. What's the probability of being a professor or a male? Well, the professors, there are 17 out of the 36. The males are 18 out of 36. How many did I double count? Who did I double count? The male professors. So I double counted 8 of the 36 of them because there are 8 male professors. So I end up with 27 out of 36, or 3/4. The probability of getting either a male or a professor is 3 out of 4. Okay, I'll let you figure out the last one on your own. There's 8 problems that you'll have to do on the second assignment. Boom.